Okay, so we are working on the last four topics of the year here. We're going to work on hyperbolas now and graphing them. But before we get into that, we should talk about the what a hyperbola is a little bit, what the formula looks like. So I'm actually going to do these on Alex for the most part. I do have a little bit of stuff that I'll write down and stuff, but as you can see, the examples are kind of tricky. So I just wanted to go through, I guess, there's two basic forms of where you're going to see or like how you're going to know something is a hyperbola. And I'm looking at them right now. The horizontal and the vertical transverse axis just basically means like a hyperbola could look like either of these two shapes. There's a lot of stuff going on, but if you look at just strictly the blue lines, that's your hyperbola. So they look kind of like parabolas that are pointing out away from each other. So some of them can be pointing to the left and right, and the other ones can be pointing up and down. But your two basic forms are going to look like this. I'm going to try to break it down as much as I can. I would definitely write down both of these standard forms. And if you look at them as you're writing them down, there's really not that much of a difference other than like x minus h is in front and then y minus k is in front on the other one. So I would pause the video now, make sure you have both of these written down before we get going with anything, and then we'll talk about what we're going to do. Okay, now that you've got them written down, I've broken it down into this. So I would pause the video again. There's a lot of writing, I know, but actually you've already written this first top part down. So if you can write down the center, the vertex, and then the asymptote slope, that's how we're going to be able to solve these, and I'll explain more in a second after you write these down what they mean. So pause the video again, write down those three things, and then we'll get going. Okay, hopefully you've written those down. We're going to get right into solving this. And really on Alex, there's three things that it's going to want. It's going to want the center, the vertex, and then the asymptote slope. My center is HK, and that's actually nice because that's been what the center has. That's how we found the center on a lot of our problems so far. The circle and the ellipse were all HK. So I'm going to go back to the question maybe. Oh, I got to go more practice. So this will be a new question. But my center for this one, since I see x's first, if we went back to this, if x is first, h is attached to the x. H is always attached to x. Even over here, if x is second, h is still attached to it. So if we're looking for hk, we're always going to look for x to figure out where h is, and we're going to look for the y to figure out where the k is. So hk in this case, it'd be the opposite of 3 for the x value of my center. So I'll go to my pencil. I'll go the opposite of 3 on the x-axis would be positive 3. And then for my k value, it's the opposite of 6, which would be down 6. So the center is going to be located right there. Okay, let's go back for a second. So we found the center. That's just hk. Now for my vertex, the direction of the variable in fraction 1 is what I have written here. Basically, whatever I see in my first fraction, which in this problem I see an x, that means we're going to be looking in the x direction. Oops, by the way, I clicked the wrong thing now that I'm looking at it. I got to use the hyperbola. This looks a lot more complicated, but yeah, it's 3 over and 6 down. That's my center. And if you can see now, it says now you're placing your vertex. It's got it written on there. So now we can go to our vertex. So back to what I was saying. In the first fraction, and these could be flipped around, but in my first fraction, I see an x. So I know I'm going to be going in the x direction with where I place my point. If the y was first, you can see where my mouse is, hopefully. That would be up and down. That's where I would be placing it. So here it says, how far am I going, or my distance is the square root of the bottom of fraction 1. So the square root of my first fraction is 16. The square root of the bottom fraction would be 4 since it's 16. So I'm going to go over 4. So 1 would be here, and it goes by the half, so you got to really be paying attention. 2, 3, and 4, I'm going to place it there. Now it says placing asymptote. Now before I get into this, you can see, this is going to be hard to see. I might have to screenshot this actually quick. Full screen snip. I'm going to zoom in. Okay. So this is what I'm looking at here. This is where my starting point is. I'm going to be basically finding a slope. And I want the slope of this line right here. So if you kind of watch what I'm doing, I'm finding that line's slope. Okay, let me get out of here. Well, I'm going to figure out what it should be. And this is where things get kind of tricky. We always want to find where k is, its denominator. We're going to take the square root of that. So it was, remember, h is always with x, k is always with y. So I want, in this case, this would be k, my 6 is k. The denominator is 9. So the square root of that would be 3. So the square root of 9, whatever that is 3. And then h's denominator, if I go back, h is always attached to x. Its denominator is 16. So I'm going to go the square root of 16, which equals 4. So basically for this problem, I'm going to need a slope of 3/4 for my asymptote. A slope of 3/4. I'm going to zoom in here so I can kind of see it a little better. That can help you on your Chromebook too. 3/4. So I'm going to rise 3, 1, 2, 3. I'm going to run 4, 1, 2, 3, 4. And before I click, I always check to make sure 1, 2, 3, 1, 2, 3, 4 looks good to me. I'm going to place my asymptote there. And that's it for this question. I mean, that's kind of a lot of stuff, but that is it. So I can check it. Hopefully we got it right. And it looks like we got that one correct. Let's go to our next topic. And I'm going to look here real quick, figure out what that one is called. It looks to me like it is the ax squared plus bx, this one right here. So this is very similar to our ellipse question we had that was ax squared plus bx or by squared equals c. All we have to do first here is change this equation. And this is going to be really tough for me to do on this screen. I'm trying to figure out how to do that. Well, I'm going to have to go into this actually. So I'll just I'm going to erase this stuff from the last problem. And then I'm going to do it over on the side. Okay, so what was that equation? It was 9x squared minus 4y squared equals 144. That's the problem we're going to do. Now, just like we did on the ellipses, these have to be equal to 1. As you can see, these are both equal to 1 in the equation. So I'm going to divide everything by 144 first. So let's see. 9 over 144. I'm assuming you can get decimals, but hopefully we don't. 144, 9. So I got 16. Okay, so this would be x squared over 16 minus 36 on the bottom equals 1. Okay, so I know that this is going to be centered at the origin because we have x and y on top without any subtraction or anything. I also know that this is a hyperbola because we got the minus sign in the middle. You could potentially get a question where there's a minus sign in front and a plus in the middle, and that would mean you just have to switch these two around because we always want that minus sign in the middle. So just be careful with that. Always want the minus sign in the middle. Okay, so let's go to our center. We know our center is at 0, 0. I'm going to click the hyperbola, go 0, 0, and click. Now I'm looking for a vertex. Remember, the vertex is, we're going in the direction of the variable in fraction 1. In this case, my variable in the first fraction, I guess here's my fraction, was x. So I'm going to be moving in the x direction when I place this point. The distance is going to be the bottom of fraction 1 square rooted. My fraction was 16, so square rooted, that would be 4. So I'm going to move 4 in either direction. 1, 2, 3, 4, right there. And now I'm going to find my slope, remember, of one of these lines. And I always go with like where my mouse is, that line right there. This asymptote slope is k's denominator. Well, h is always attached to x, so k would be over here. The square root of 36 is what we would use then, divided by the square root of h's denominator, which would be 16. So 36 divided by 16, if they're both square rooted, that'd be 6 over 4. Or I guess we could rewrite that as 3 over 2. So I'm going to go up 3 over 2 for my slope. Again, I'm going to zoom in. Up 3, 1, 2, 3, over 2, 1, 2 would be right there. This looks like my hyperbola. I'll check to make sure we did it right, and good, we got it right. So we can move on to the last topic. That last topic was graphing a hyperbola given its equation in general form. That's topic 12. Where are you, general form? Oops, must be at the front for some reason. There it is. So this is the question. And actually, I'm just going to snip this. And bring it onto here. I'm going to zoom out a bit. I'll paste it right there. And then let's solve this. Well, we're not even going to really solve it. We're going to create our hyperbola equation. So it's kind of similar to the ellipse. We're going to do some completing the square and all that stuff. We're going to have to make it equal to 1. So let's get going with this. First step would be to move the x's in front. That's how I always do these. I always move the x to the front. So if I do that, I'll have 4x squared plus 16x. And then I'll have minus y squared minus 8y. And then I'm going to move that 16 to the other side. Now we can anti-distribute that 4 or factor out of 4. And then we'll be left with x squared plus 4x. Oops. Oh, not yx. I don't know why it's not erasing. Oh no, I might have lost my marker. Hang on one second. Ran out of battery. I can plug it in though. There we go. That's better. Okay, so that would be 4x because I pulled out an x. Leave some room, and then we'll go minus. I'm going to take that minus out. So I'm basically removing that so that I could have a positive y squared. And then this would be plus 4y. Yep, we're charging it. And then that's going to be, I'm going to leave a space there, and then this will be equal to 16. Okay, so then I need to fill in the blanks here. So I'm going to fill in a 4 here. I guess I'm also filling in a 4 over here. Okay, and so if I factor those, I'll have 4 and then x plus 2 squared minus y plus 2 squared equals 16. And I guess I forgot to do something in the last problem. I added 4, well actually I added 16 there, and then I subtracted 4 because there's a minus sign out front. So I subtracted 4 and added 16. That means I really just added 12. So therefore we would be at, instead of 16, I will put 28. Now if I divide everything by 28, I should get a 1 on that side, which is what I'm looking for. So 4 over 28 would be 7 on the bottom, minus, we got 28 on the bottom, so y plus 2 over 28, make sure that's squared, equals 1. And even though it's pretty sloppily written, this is your formula for the hyperbola. And notice we've got the minus in the middle. If the minus was out front, we'd have to flip the 2 around so that minus sign was in the middle. Now we could graph it. I can do that quick. So if I go back to graphing, zoom out here. My center looks like it's at -2, -2. That's where HK is. -2, -2. Place that there. Again, if we got to look back, your vertex is in the direction of the variable in fraction 1. Oops, my fraction is over here. So it's in the direction of x. And then we move the direction, or the distance is the bottom of fraction 1 square rooted. Now we have a 7 there. Did we do something wrong? We must have done something wrong. What am I mistaken on? 16 and 4 would be 12. Sorry, I'm trying to figure out. Something must have went wrong because we should be able to take the square root of that bottom. I don't think they're going to make you do a decimal on that. Hopefully you're seeing it and I'm not. Four over 28. That is 7, right? 16 plus 12 is 28. We did really add 28, right? We added 16 and we subtracted 4. I don't know. I'm not seeing what's wrong. I guess we could always look at the example and or the explanation and just see. That would be easier than you waiting around for me. So let's see here. We did some silly mistake. 16 plus 16 minus 16. Why did they add it and subtract it? Did I write down the problem wrong? 8y. Oh, I did. I wrote this down wrong. Sorry if you've been with me the full time. This should have been an 8. I knew we made some silly mistake somewhere. I shouldn't have pulled out. I shouldn't have made this a 4. Here, let's fix this quick. So that should be an 8, which means this would be a 16. There we go. So therefore, that's why they're subtracting 16 and adding 16. And so therefore, this number should be a 16, which means we're dividing by 16, dividing by 16, dividing by 16. So this would be a 4 on the bottom. But hey, this is actually good because you guys can see, like, if you don't get a perfect square on the bottom, there's probably something that you did wrong. So this would be a 16 down there. That's better. Now we can go in the direction. Well, we've already kind of ruined it because we had to click on the example, but you can look. We're going in 2 to the left and 2 to the right. So as you can see, there's a point right where my mouse is. Maybe you can't see it right here. There's a point. That's 2 over from the center. And then also the last step was the slope, which we'll be able to see in a second. But the asymptotic slope is k's denominator divided by h's denominator, which would be, in this case, k's denominator was 16, so it's going to be the square root of that. So we get 4 over 2. So we're rising basically 2 over 1. So let's check to make sure. As you can see, that slope of that line is rise 2, run 1, right there. So yeah, sorry for that mistake, but I guess we figured it out. It was just a silly mistake. You got to be careful. There's a lot of stuff going on. There's a very good chance you can make a silly mistake. So let's go on to the last topic now. The last topic says classifying conics by their equations. Now, I've done a bunch of these, so I might not get into it super deep, but basically they're going to give you these forms, and you're going to have to rearrange and complete the square until you figure out what shape it is. Now, we didn't really talk about parabolas other than the fact that it's going to look like it's going to look something like this. You'll have, I don't know, a times x minus h squared plus k. And that's going to be your vertex form. So if we can get these to look something like this, then that would be a parabola. I also know that I'm going to find a parabola. There's a really easy way to know that you're going to pick a parabola. When you look at the question and you only have one exponent of 2. I know this first one's going to be a parabola because we don't have both exponents being squared. For a circle, an ellipse, and a hyperbola, you would need 2 of those. So I know that that letter B is not going to be a parabola also. So that should help a little bit. For that first one, if I start completing the square, I'm going to have to complete the square with those because I've got the squared there. So -4, I'm going to skip a step here and go right to y squared plus, sorry, that'd be a minus if I pulled out a -4, -6. And then I'm going to leave some room. And then actually on this one, typically we'd move this 35 over, and you could do that, but I know it's going to look like a parabola. And so that number is just going to kind of hang on there. So I'm going to leave that -35 right where it's at, and I'm going to move the x to the other side. I'll show you why in just a second. Now I got to fill in this blank with something. That would be +9. So if I fill it in with +9, what I've really done to the left-hand side is added a negative, sorry, I've added a -36. That means I don't really want to put the -36 on the right-hand side. I'm going to put it right here. I'm going to put +36 to cancel it out. Because we added a -36, and now we'll add a +36, and we'll have it canceled. So then I can factor. So I'll get y squared, not y squared. It'll just be y minus 3 squared, and this will be +1 equals x. Now, if you look at this equation, it looks somewhat like this, but it's kind of backwards. Usually we have y by itself, and x is in this location. Well, this would just be a case where instead of a parabola, a normal parabola that it looks like this or like this, these parabolas would look something like this or like this. So if y and x have changed places, the parabola is actually a sideways parabola, which you've probably never seen before. That just means it's not a big deal. It's just a parabola. But then there's one more thing. It's going to ask you a question after you pick parabola up here. It's going to say, what's your vertex? Now that's going to be a little bit different because over here your vertex would be hk. It's the opposite of h and then whatever k is. In this case, it's kind of backwards. Since y is in the wrong spot, it's where x is supposed to be. Your h is actually going to be located right there, and k is going to be located right there. So the vertex for this one is going to be 1, +3, because it's still the opposite of this and whatever this is, but my vertex is right there for that problem. That's kind of tricky. Take a minute, try to do that one again, or try to do a different problem that looks kind of like that on Alex if you can. But yeah, that's it for the first one. That's a doozy for a first one because it's a different parabola than probably you've ever seen. If I go through the second one, actually, I'm kind of out of time, so I'm probably not going to go through the second one. I can tell you what to look out for, though. Basically, here we go. I'll show you. If it turns out looking like one of these two, where you've got a subtraction symbol between them, and even if the subtraction symbol's out front, you'd want to switch them around anyway to put the subtraction in the middle. But if you've got a subtraction problem, that would be a hyperbola. And it's going to ask you for the center on those, and you can find those by using h and k. If it was an ellipse, we know it's an ellipse when it has a plus sign between them. If it was a circle, it's going to look like this, where you've got a plus sign between them, but you've got a radius squared that and you don't really have these fractions on the bottom or whatever. I don't know, whatever that is. So that's what a circle would look like, and we've done enough examples of those. Like if you wanted to look at example 5, we did an example of that. in example, let's see, what else did we do? Looks like example 9, we did an example of that. And then obviously we just got done doing one on example 12. So I'd look at those examples for letter B. But yeah, that's it for the year on topics. So I'm going to keep this kind of short. Thanks for watching. And if you have any questions, make sure you ask in class, please.